This video is designed to cover 14.3s, properties of quadratic graphs. Remember, a quadratic graph is a U-shaped graph. It's because there's x squared on one side of the equation. So y equals 2x squared plus 3x minus 4 would be the example. Remember, those linear graphs are straight lines. The highest power of x is just x, so 3x plus 2. No x squareds involved. So just a reminder, there's a quadratic graph in black and a linear graph in red. Remember, we spoke about turning points. The bottom of the graph, the lowest point, where it stops going down and starts going up. The intercept, just like on a linear graph, quadratic graph goes through the y-axis somewhere. We call that the intercept. And it also has roots, where it goes to the x-axis. Also has a line of symmetry, and the line of symmetry will be x equals. On this graph we're looking at, the line of symmetry is x equals minus 1. That's straight line going up, and it's symmetrical about that. We looked at how to plot them, and you will need to be doing that in 14.3s as you sketch some graphs, so remember that. And these are the examples. But here's just a recap of the properties I want you to remember. Remember, we get these quadratic graphs because when we square a negative number, minus 3 times minus 3 is 9. And that's what makes it a U-shape. If there's an x squared in the equation, that's the highest power, then we don't get a linear graph, we get a quadratic graph, which is called a parabola. If there's an x cubed, we call that a cubic graph, and that's a different shape. We'll come on to look at that in graph 2. It's very exciting, I know. So parabolas, as we said, are symmetrical U-shaped graphs. Intercepts, like a linear graph, turning points, and roots. I quite like this slide because it's a nice summary. Extra bit of skill that goes back to chapter 10 that is used in this exercise is completing the square. The point of completing the square is to help you find the turning point. Some of you ask me, what's the point? Well, now you're going to find out. So this is a square bracket, x plus 4 times x plus 4. I'll show you how to do this in a moment on paper. The number in here tells me the x coordinate of the turning point. It's an opposite sign to that. So the turning point for this one is where x is minus 4. The y value of the turning point is given by the number there. So if we look on the graph, the turning point is minus 4, opposite side to that, 2. So when we know how to complete the square and create an equation that looks like that, it helps us find the turning point. Question 1 should be okay because it's asking you to sketch a graph, so you'll need to work out some values. And it's saying put it on the same axes so you can compare these three graphs to each other. Which function has a maximum? So that means which graph has got that shape, so the maximum will be the top point. I know which one it is, but I'll see if you can work it out. Which function has 2 roots? So that means if we've got the x and y axis, which function goes through the x-axis twice and has 2 roots? Okay, number 2 gives you a series of functions and it's asking you to find 3 of the properties. The equation of the line of symmetry, which you should be able to see visually and give an answer of x equals to whatever the line is. The number of roots, so again you can see how many times it goes through the x-axis, and that could be 0, 1 or 2. Just to give you the idea of what we mean by 1 is where the graph just touches the x-axis and then goes up. And then the coordinate of the turning point. So the turning point, again, you can read that off and look at that. Some of the later questions we will be doing that algebraically. And I'll be taking those, or taking you to those now. So number 3, we're looking at there, using those sketches, trying to match the equations to each one of those. We looked at those skills in the last exercise. And then this one is asking you to use algebra to find the roots of these functions. So this is what I'm going to do on paper for you. And again, it's something you might want to go back and have a look at chapter 10 for to help you. But this first one, because we've only got 2 terms, is similar to the example I did in the extension for the last exercise, which I'm pretty sure was lesson 48A. If we look over here, we've got some star questions. They are tough ones, but I'm sure most of you can do this with hard work and hopefully my help on the video. This is about putting something in the form of completing a square. So I'll be doing this on paper for you. And then we'll be using that as we did on that previous PowerPoint slide. And this, some of you might recognise, b squared minus 4ac comes from that quadratic function that we can all recite, minus b plus or minus the square root of b squared minus 4ac all over 2a. And that again comes from chapter 10. So I'll be taking you through these on paper just to give you a hand. Okay.
This is similar to the question in the previous example where I had to factorise something that just had an x squared term and an x term, no number on the end. Reasonably straightforward. If we take x out of each term, x multiplied by x gets you back to that x squared that I need. X multiplied by minus 8 takes you back to the minus 8x I need. So this is that equation factorised. The roots of the equation are where y is equal to 0, because that's the equation of the x-axis. Where they go through the x-axis, y is equal to 0. So I want to know what values of x make this equation equal to 0. And as I saw in the last video, to make that happen, this is going to be 0 or that's going to be 0. So my values of x are going to be x equals 0, because then this will equal 0 on this side, or x equals 8. Because 8 take away 8 will give me 0 in this bracket. 0 times anything out there will give me that answer that I need. I now need to use these values to work out the value of y. So I put these values back in here. Using the value 0, x squared is 0, take away 8 times 0 is 0. So the first root is 0, 0. The other root is going to be x equals 8. If I put 8 back in the equation, 8 squared is 64, multiplied by 8 times 8, 64, gives me 0. And that's what it should be. Both of these should be 0 to make them the roots. So in effect, I just need to work out these x coordinates to work out the root. Because if y isn't 0, it's not a root. Now, question 5, and I'm looking at part D. This time I have got x squared, x, and a number. So I could factorise it if it's factorisable, or you might have to use the quadratic formula, minus b plus or minus square root of b squared minus 4ac over 2a, or you could complete the squares. For this one, and for in fact all of this question, question 5, they are going to be able to be factorised. So that means I'm going to have a double bracket, x at the front of each of these, and this again comes from chapter 10. Remember now to factorise a quadratic. 2 numbers that multiply to give you minus 12. Well, the factors of 12 are 1 and 12, 2 and 6, 3 and 4. Now, to find the actual ones that go here out of these possible factor pairs, I need to have the difference of these being 1, because I've got 1x. I'm saying difference in this case because it's got minus, so it means one of them is plus and one of them is minus. So here is one where the difference between them, it will be 1. In this case I'm going to have a plus 4 and minus 3, because that will give me a total of 1x when I multiply this out, because this would give me minus 3x, this could be plus 4x, so in total that gives me the x there. I will show you a positive one as well to remind you about factorising. But now I've got the x values, and remember when I'm looking for the roots, for this to be equal to 0, which is where the roots are when y equals 0, this has got to be 0, so the x value is actually minus 4, opposite to that, and the other x value is the opposite of that, plus 3. Going back to C, I've now got a plus x and a plus there, so that means both of my numbers are going to be positive. I will warn you one tricky one coming up later. So two numbers that multiply together to give me 6. The possible ones are 1 and 6 or 3 and 2. Now because they're both going to be positive, I need them to add up to 5. So I know it's 3 and 2. This will give me 3x, that will give me 2x, so in total that gives me the 5x. Again, I want that to be equal to 0 to give me the roots. So that means it's going to be x is equal to minus 3 and minus 2. So this is F, this is the one to look out for, because we've got a positive here. So you might think both of them are positive in the brackets, but we've got a negative here. That actually comes to the fact that they're both negative. Both the numbers in the bracket are negative. So if I do a negative times a negative, I get that positive. But obviously I've got a takeaway and a takeaway, so that's what gives me the minus 5x. I won't ruin the fun of you factorising it, but that's just one to look out for. Question 6 is similar. Again, we're using algebra to find the roots. So you've got the various methods you can use for that. Just pointing out this one. When I've got no x term, remember when I've got this, what we call difference of two squares. This is x plus 4, x minus 4. Because this will give me minus 4x, this will give me plus 4x, so I've got no x values. Plus 4 times minus 4 gives me the minus 16. So look out for that. You've got that as well in part C of this question.
The exercise was a tough one, lots of ideas in there, and again some of you might need to do chapter 10 or a revision of chapter 10 just to help you do that one. That, as I say, will be uploaded over the half term, and hopefully that'll be of use to you. This video has gone over 15 minutes, so it is split into 2 parts, so make sure you watch both parts, or maybe watch it in sections when you've done a few questions. But I think all the skills that you need to get through this exercise are there in one of the 2 videos for 14.3. Okay, that's it. My beloved quadratic graphs. The strange thing is 14.4 for me is much easier. So might be a case if you want to do 14.4, there's been a light relief. But then I'm a mathematician, so I love this stuff. Okay, hope you're all right. And again, hope to see you soon. Take care. Bye-bye.